With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, the figure shows a wire PQRSTXYZ placed in a time-varying magnetic field given as B is equals to beta T. Beta is positive constant resistance per unit length is lambda. Find the current induced in the wire and draw the electrical equivalent. So if you see, these are the two rectangle. If you see here, the two squares basically. So if you see, this square is having a area A1, that is B square, and this is having area A2, that is A square. If you see here, the beta is a positive constant. So if you see, the inward magnetic field is increasing, right? So we know that the magnetic flux, if I write down, we know that it is BA cos theta. So if you see here, they are already, you can see they are already parallel, so it will be BA, right? So if you see, the inward flux is increasing here, since the beta is constant and the time will increase it, then the magnetic field will also increases, right? So if you see, the magnetic field is increasing, so the induced EMF will be having a direction so that it could oppose the induced current. So if I talk about the induced EMF direction, so it should be in a direction. So if you see, we want the flux generate to out of the plane, so it will be this, and the battery will be having this. And if you see here also the inward flux is increasing, right? So if you write down the battery here, so it will be also like this, right? And let's say the current here is I, right? And you can write down this is E2. So we know that the E1 and E2, from the Faraday's law, we know that the induced EMF have a magnitude d phi by dt. Magnitude, right? Direction we already have seen. So if you see, the area we already have seen, the magnetic field is beta T, right? So I will write down the flux through the loop 1, this is the one loop, it is B into A1, so it is beta B square into T. So E1 will be d phi 1 by dt, so it is beta B square. So similarly, we will write down the induced EMF for the second. It is beta A square T. It is d phi by dt. So you can see the polarity of the battery. The positive terminal is connected with the positive terminal. And if I talk about the net resistance of the circuit, so if you see here, all the resistance are in series, and total length you can see 4A plus 4B. Right? If you see, the length are in already series, so we will write down the resistance per unit length is lambda and total length is 4A plus 4B. So we will take this 4 outside. So this will be the total resistance, and the net EMF, it will be E2 minus E1. E1 minus E2. Here the B is more. So we will get beta B square minus A square. So I will write down the current through the battery I is equals to the net resistance. The value. So if you see, this is beta. So B square minus A square. So we could write down this as this. And the R equivalent we already wrote, it is 4 lambda A plus B. 4 lambda A plus B. So A plus B will get cancelled out. And this will be the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.